In the previous video in this series, we looked at how to become a Sherlock Holmes of the data platform. We explored monitoring and logging and how query logs can help you investigate what happened in the system. So, who runs a query, what data was accessed, and who tried to access something that they definitely shouldn't have tried to. But there is one small problem with this detective approach. Sherlock Holmes usually starts the investigation after something suspicious happens. And in real environments, nobody sits there and all day clicking and checking logs hoping to discover that crime. Something needs to detect suspicious activity automatically, or maybe even automagically, and raise the alarm. And that's exactly what alerting systems do. In most data platforms, modern data platforms, those alerts are surprisingly simple. They usually just queries that look for suspicious patterns in platform telemetry. In this video, we will look at 5 practical alert rules that are commonly used to detect security relevant events in data platforms. And then we are going to implement one of them directly in Snowflake just for the demo purposes. And quick recap from the previous video, monitoring and alerting serve different purposes. Monitoring gives you visibility into what is happening into the system, and alerting provides a detection when something unusual occurs. You can think about it like this. Monitoring is like viewing the case files, and alerting is a system that rings the bell when something suspicious happens. And ideally, that bell rings only when something that really matters rings, and not every time a dog barks at the corner, or something like that. There are generally 2 ways to implement alerting for data platforms. The first option is to send logs to a centralized monitoring system. For example, you can send logs to Datadog or Splunk or Elasticsearch or any other CM systems, and then those will raise the alerts. In this model, the data platform exports its logs into the central place where all of the logs are collected together, and the detection rules are the generic ones on top of everything else. And alerts are configured there, as I said. The second option is slightly simpler and not as enterprisey, if you want. It's basically to run the detection rules directly in that data platform. Here, platform periodically checks the queries against its own telemetry and triggers actions when suspicious events are detected. That's what we are going to implement. But regardless of which architecture you choose, the core idea is usually the same. Alert rules are just queries that detect suspicious patterns in platform activity. Now, top 5 security alerts for data platforms. Let's look at what are the most commonly used queries that we can implement. And those are not specific to Snowflakes. The same ideas apply to most modern data platforms. A single failed query usually isn't very interesting. It might just mean that someone made a typo while they were typing the query, or they forgot what schema they are in at the moment and run incorrect query, or correct query but in the incorrect database. But repeated failures in a short period of time, that can indicate something more suspicious. For example, someone is probing for accessible tables and going through commonly named tables one by one in a given database, or just a misconfigured automation that hits your database again and again and again with the same wrongly typed query, which should be fixed, or just someone trying a bit too hard to access restricted data again and again and again, as usual. A good detection rule, therefore, looks for patterns and not for a single event. Second alert rule is to access sensitive tables. Many organizations maintain a list of sensitive datasets. Things like customer information or financial records or personally identifiable data, or if it is a health industry, then some patient information. And alerts can be triggered whether those datasets are accessed or not in any case. Not because every query is suspicious, but because those datasets are high value targets and you don't want to miss anything that is happening about those datasets. Another useful signal is activity outside normal working hours. So, for example, queries that are executed at 3 a.m. in the morning or during weekends, and there are a lot of them, or when accounts suddenly running queries at times when they normally don't. And if your organization works 8 to 5 on weekdays, and those queries at 3 a.m. just starting to pop up in your monitoring queries, that usually means something wrong is happening, unless you were notified that, well, someone actually needs to work overnight for some reason, or there is a new department from overseas or something like that. So basically, it was investigation anyways. Another common signal is unusually large queries. For example, queries scanning very large volumes of data, select star something. Those can sometimes indicate data exfiltration attempts, or it can simply mean someone wrote a query and forgot their where clause as well. But both of those worth knowing about and with investigation, either from a security perspective or from a performance optimization perspective. And the last one, it can be useful to monitor activity performed with privileged roles. So, for example, administrative roles. Those roles have powerful permissions and are usually meant to be used very carefully. If such roles suddenly start running unexpected queries, it might worth taking a closer look and have a chat with those users about following the principle of least privilege. Well, just saying. Now, before implementing alert rules like those, there is an important challenge to consider: alert fatigue. If alerts trigger too often, people quickly learn to ignore them, and we all were there, right? Once alerts are ignored, they just basically become useless. This is particularly common in data platforms because there are a lot of automated activities. Typical environments have ingestion pipelines, transformation jobs, orchestration tools, BI dashboards, and all of those generate queries, different type of queries, as in different types of datasets in different hours of day. And sometimes those can be just hundreds of queries per hour. And if alerts are not designed carefully, they will constantly trigger again and again and again, and they will trigger on those completely normal activities. There are several ways to reduce this. First, exclude known automation accounts from the queries. Second, alert on patterns rather just a single event, as we spoke about the very first alert rule. And third, focus on sensitive datasets rather than everything. And finally, use thresholds. A good alert rule doesn't detect activity, it does detect unusual activity. Now, as promised, let's implement one of those alerts in Snowflake itself. And in order to do that, we need to do a couple of things. First of all, it is possible to send notifications from Snowflake directly to external systems. So, for example, using this system send email function, but in trial account, all of those external integrations are disabled. So I am not going to use those, and yes, it is possible to send not only the emails, but on top of that it is possible to send notifications to webhooks, for example into Slack. But what I'm going to implement is I'm going to create a temporary table, temporary in case that it is going to be used only for the demo purposes. Security alert log with just a timestamp and a message. And I am going to create a procedure that is notify security that will just insert into that newly created table a current timestamp and a failed query detected message. It can be much more complicated than that, but for them purposes that will do. And after that, the alert itself is pretty simple. It can be done with create or replace alert, and then on what warehouse it is used, and how often this query will be executed. So I want to run my query every 5 minutes. Then it will have a condition, so if exists, select one, and here is a trick that I wanted to show. Instead of using the query history, which can have a latency, as I understand it, up to 45 or 90 minutes, you can use this information schema query history as a table and query it directly. That way you basically ignore the latency and query all of the actions immediately. And what I'm going to do, I am checking the execution status is failed with years. This is once again just an example, and a bad example would be to have a query that are not successful or that are not running at the moment, and limit the start time of 5 minutes before now and up until now. So if there would be any queries that are failing with years, then it will trigger the alert anyone. And when that alert is triggered, we call that notify security stored procedure that I just showed you. It could be inserted into the log table, or it can call the external function or the external integration like that. And one more thing that we need to do is when the alert is created for the first time, it will actually be created in a suspended state, and we need to start it. It is done with alter alert resume statement. After that, when you are happy, it is possible to alter that alert and suspend it yet again, so it will not run anymore and will not consume your compute power. That's pretty much it. With that setup, we can start the alert. It will run every 5 minutes and query for failed queries as we wanted. And after something bad happened, we can always just select star from this alert log and see that, yeah, there were some issues detected, failed queries detected from our query log. Cool. That was just a quick demo, and in general, alerting in modern data platforms often look a lot like data analysis. The only difference is that instead of analyzing the business data, we are analyzing the behavior of the platform itself.